Good evening. This is Ksp2 solubility in grams per liter or even into moles per liter. Last night we talked about how if you had solubility in grams per liter or moles per liter, you went to Ksp. We're going to reverse it tonight and go the other way around. So we have a problem here. Calcium fluoride, solid, has a Ksp value of 3.9 times 10 to the negative 11th, which is a pretty small value. And then we are going to be asked to calculate the solubility in grams per liter. So we're going backwards from what we did last night, like I said before. So let's jump right into this. The first thing we're going to do is we're going to write a dissociation equation for when calcium fluoride dissolves in water, even though it doesn't dissolve very much. So there we go. We have our calcium fluoride. It's going to form the calcium ion, plus it's going to form the fluoride ion, both in aqueous forms. And because we have two fluoride ions, we are going to have a coefficient of 2 right here, and that's going to be important. This is going to become an ice table problem, so I'm going to ice table this. And one of the things we have to remember on ice table problem is we're not going to be worried about our solids. We're only going to be worried about our products that are aqueous. In this case, because Ksp is going to equal the calcium ion multiplied by the fluoride ion, and again we're going to have to square that guy because we have a coefficient of 2 from the balanced equation. Okay, so we're ready to start. Now we're going to kind of work this backwards. We know our reaction is going to the right. We don't have any of this. We're going to have plus x here. We're going to have plus 2x there, x and 2x, and that's all we have to work with. But we do know some other information. And so we do know up here we have 3.9 times 10 to the negative 11th as our Ksp value. So we're going to go 3.9 times 10 to the negative 11th is equal to. Now what I'm going to do is plug in my unknowns, which I have x and I also have 2x to be plugged in, and we're going to have to square that. So really, to find the molar solubility, we're going to just solve for x, and so let's go ahead and do that right now. Now I know your math skills are up to par, but let's just double check and make sure we have it all together here. So we have 3.9 times 10 to the negative 11th is equal to x multiplied. Now we're going to square 2x, so we're going to get 4x squared. We're then going to multiply 4x by x, or excuse me, 4x squared by x, so we get 4x cubed is equal to 3.9 times 10 to the negative 11th. Alrighty there. We want to solve this guy for x, so we're going to divide both sides by 4. It's going to cancel x on that side. And then if we want to get rid of the x cubed, we're going to take the cube root of both sides. Okay, so that'll leave us with x here. And when I ran this through my calculator, actually what I want to make sure we do is I'm going to throw this in parentheses first, so my calculator takes care of that first before doing the cube root. I do come out with an answer equal to 2.1 times 10 to the negative 4th is equal to x. Now, this is going to be equal to moles per liter. This is our molar solubility. And so I'm just going to scroll up here to the top, and I believe it asked me for in grams per liter. So what we're going to do then is we're going to take this value of 2.1 times 10 to the negative 4th moles per liter, and we are going to convert this to grams. 1 mole on the bottom. Now, once again, we do have calcium fluoride, and so I just need to calculate the molar mass of my calcium fluoride there, which is 78.07. And so what I'm going to do now is just multiply those two values together. I'm going to get moles canceling with moles. I'm going to get an answer in grams per liter, which is our solubility, which is going to be 1.56 times 10 to the negative 2nd grams per liter as our answer. Once again, we're given Ksp. We do an ice table. We're going to run it through the ice table with x and 2x because of our coefficients, and then we just plug that into the Ksp expression and solve for x, get this molar solubility. Now, I'm going to let you try a problem here yourself, and Let me scroll this down just a little bit more for you so you can see it. Okay, so again, there's the problem. We have the Ksp for LaF3 is 2.8 times 10 to the negative 19th. And what you're going to be asked to do is calculate the molar solubility in moles per liter. Essentially, molar solubility, again, is you're solving for X in this problem. So you can pause the video right now and work it. And then in a couple minutes, I'm going to go ahead and work the answer, and we'll double check and see if we get the same thing. See if we don't, you can always post up questions in the stream. Okay, now you paused the video, right? And you worked it out? You're shaking your head up and down, yes? Good. So let's work this out now. So we're going to take LaF3. Oops. That's going to be a 1 minus. And again, subscript of 3, coefficient of 3 there. Ice table this guy. Not worrying about my solid. Starting with nothing and nothing. And so this is going to be plus x here, plus 3x here, x and 3x. Okay. What we'll do now is we're going to write our Ksp expression. So Ksp is equal to La3 plus F1 minus. We're going to cube that guy. And now we're just going to plug our values in here. So it did give us the Ksp value of 2.0 times 10 to the negative 19th is equal to x multiplied by 3x cubed. 3x cubed gives us 27x cubed multiplied by x. It's going to give us 27x to the 4th power, 2.0 times 10 to the negative 19th. Basically, now we just have to solve for x. Again, dividing both sides by 27. Canceling there, we're left with x to the 4th. And what we're going to do is we're going to take 4th root on both sides. So that's going to give us x there. Put that in parentheses. And when I divided that through, I got 9.28 times 10 to the negative 6th moles per liter, or molar solubility. Now, if we were asked to try to calculate grams per liter of solubility, what we would need to do is we would just need to make sure that we multiplied by the molar mass of lanthanum fluoride, LaF3. But we weren't asked for that in this problem, so we're done. Have a nice evening.